Right now, let's start this function, which is a quadratic function. Quadratic function. Quadratic function. Right, a quadratic function is also known as a parabola. It's a parabola. It has got this shape or that shape. That's a quadratic function, which means it has got a turning point. It is given by this equation. F at x equals ax squared plus bx plus c. It's ax squared plus bx plus c. Or it can have this equation. G at x equals a into x minus x1 into x minus x2. X times x, that is x squared. These are the roots, x1 and x2 are the roots, but then let's continue. We are going to look back on this one. The other equation for a quadratic function, it can be a into x minus p all squared plus q. It's a into x minus p all squared plus q. Right, all these we call them quadratic function. Right, now let's look at this one here. Y equals ax squared plus bx plus c. Right, for us to sketch a graph, remember that we need to find x and y intercept. For here, for x-intercept, obvious, for y-intercept first, you let x to be 0. So if you let x to be 0 there, you will be remaining with c. Therefore, our y-intercept will be 0 is to c. C represent the y-intercept after letting x to be 0. And then for x-intercept, you are to let y to be 0. We let y to be 0, right? If y is 0, there you will be remaining with ax squared plus bx plus c equals 0 for x-intercept. And then from there, the next step you will have to factorize. If there are no factors, you complete a square. Let us solve for x here. Divide by a. After dividing by a there, you'll be remaining with x squared plus b over ax plus c over a. This is equal to 0, right? Let us now try to complete a square. It's plus b over ax. We are transposing this, it's c over a. So if you are to complete a square, you halve the coefficient of the middle term. The coefficient of the middle term, you halve it. For instance, if you have 4, and then you are to halve 4. To halve 4, that means you are multiplying 4 by 1 over 2. You halve this. So this will be 4 over 2, which is equal to 2. You are halving. If you are to halve something, you multiply that thing by 1 over 2. We do the same here. To complete a square, we halve the coefficient of the middle term. Therefore, here we are going to have x squared plus b over ax plus, and then we halve this and put square there. What you do on the left, you also do it on the right. It's minus c over a plus. Remember, we are completing a square. We are completing a square. The number that we are going to put here has to be the same as that one. What you do on the left, you also do it on the right. So we have added same value here. Let's halve this. It's 1 over 2. The coefficient here is positive b over a. We are halving that coefficient. So 1 times b, it's b. 2 times a, that will be 2a. So since we have done this on the left, we will also have to do it on the right. It's b over 2a, like that. Right, thereafter, we have to factorize this. Let's say you have x squared plus 4x plus 4 equals 0. If you have this, you are to factorize this, right? It's x plus 2 into x plus 2 to factorize this. Let's say you were to complete a square. It's x squared plus 4x plus, we are completing a square, transpose 4, it's minus 4 plus. And then now you are to halve the coefficient. We divide by 2. We are halving 4. So it's 2 and 2, like that. And then from this step, we factorize. Remember, we've got 2 squared. To factorize this, when you look at this, it is the same as that, because 2 squared is 4. So to factorize this, it's x, and then you take 2 as it is. You take that number inside the brackets there as it is. It's plus 2. And then you say all squared. As you can see here, it's x plus 2 into x plus 2, which means it's x plus 2 all squared, because this repeats itself 2 times. Same thing will be applied there. We do the same here. We are going to take this as it is. So it's x plus b over 2a, and then all squared. It's all squared. This will give us that, if you are to go back, equal to, we solve there, it's minus c over a plus, this will be b squared. It's b squared over 2 squared, that is 4a squared. It's 4a squared. Right. Now we are having x plus b over 2a all squared, which is equal to, let's write this with b squared on the left. It's b squared over 4a squared minus c over a. When you look there, we are subtracting fractions, therefore we will have to take an LCD. So now we are having x plus b over 2a all squared equals our LCD. It's 4a squared. It's 4a squared. 4a squared. And then now we are dividing. 4a squared divided by 4a squared, it's 1 1 times b squared, it's b squared. That will give us b squared minus 4a squared. 4a squared divided by a. Let's go. We are left with 4a and then we multiply. You divide and then multiply. It's 4a squared divided by a, that is 4a, and then multiply by the numerator. It will be 4ac. It's 4ac, like that. Right. And then from this step, remember that we want to solve for x. So in order for us to solve for x, we will have to apply the root sign on both sides. To get rid of squared, you will have to apply the root sign. Right. Now we are left with x plus b over 2a, which is equal to, remember that the answer that you obtain under the square root, it can be either plus or minus. Right. Here, if you have a 9 over 4 and you are to put a root sign, this is the same as square root of 9 divided by square root of 4, which will give us 3 over 2. It's plus or minus. It's plus or minus. Plus or minus 3 over 2 if you are to divide that. Same thing here. It's square root of b squared minus 4ac over square root of 4a squared. Our numerator, since there is a sign in between here, so this will be as it is. It's b squared minus 4ac divided. Square root of 4 is 2. Square root of a squared, it's a. That's what we have. And then remember, we are to find the roots. We are to find the roots. We have let y to be 0. So in other words, we are to find the x-intercept, which are the roots. Therefore, let us now solve for x. X will be equal to, we are transposing that so that we'll be left with x, what we are to solve then. It will be minus b over 2a plus or minus square root of b squared minus 4ac all over 2a. When you add or subtract fractions, we need to take the LCD. Therefore, our x will be equal to the LCD here, it's 2a. It's 2a. 2a divided by 2a, it's 1. 1 times negative b, it will be minus b. And then we take that sign, plus or minus. 2a divided by 2a, it's 1. 1 times the numerator, it will be b squared minus 4ac. These are our roots. These are our x-intercept. If you are to solve for x, then you just complete a square and get that answer, which is our x-intercept, right? Therefore, let's continue. Right. Since we are talking of a quadratic function, it has got one turning point. It has got one turning point since it's given by ax squared. It's ax squared plus bx plus c. It's ax squared plus bx plus c. Right? From the same equation, we have find the x-intercept, as you can see, and then to find the turning point. Remember, we have to find the turning point, since it has got a turning point. To find the turning point for maximum or minimum, it's maximum, and then it's minimum. So for maximum or minimum, we derive. Remember, we derive 2 times a, that is 2. A, we subtract 1 up there, that will be 2ax. 1 times b, it's b, so it's x exponent 1 minus 1, which is 0, x exponent 0, it's 1. That's what we have. This is the gradient of a tangent to the function of y. We are to find the coordinates for minimum or maximum. So we have derived this. After deriving, remember this is the gradient of a tangent. The gradient of a tangent at a turning point is 0. Therefore, we let the derivative to be 0. Now we are having 2ax plus b equals 0. And then we transpose b. 2ax will be equal to negative b. And then we are to solve for x, we divide by 2a. We divide by 2a on both sides. This goes, therefore, our x is equal to negative b over 2a. This is the x value at the turning point of a quadratic function. This is the x value at the turning point. At the turning point of a quadratic function. Right, for y value, you take this value, substitute it into the original equation to find our y. Our y is an original equation. So to see what is the value of y if x is equal to this, because they have to be x is to y. So you compare the two. If x is equal to this, what is the value of y? In other words, you use this value in the place of x to find the value of y. Right. Let's continue. So we've got another equation. We are done here. We substitute the value into original equation to find the y value. Right. We've got this equation. G at x is equal to a into x minus x1 into x minus x2. Where this is our y, x, x. Therefore, x is to g at x. This is our given point. It's a given point or any point. This is any point in a function. Right. We've got a. A always tells us about the shape. determines the shape.